Hi, this is Marwa, and today we will be doing another video about functions, but we will focus on the composition of functions. We have discussed functions operations before. We did discuss how to add, subtract, multiply, and divide functions, and how the domain of those functions will be affected when we do that. Today we'll be discussing something else, another type of operations, which is a composition of functions. So let's see what we have. Now here we're going to start off with the rule. It says here the composition of the functions the function g with function f is written as g composition f and is defined as g composition f of x equals g of f of x. What does that mean? It means that you have two different functions, g of x and f of x. The domain of those functions is known to you. For the function f, you're gonna take all the values of x, substitute into function f, and you're gonna get the output, which is f of x. You're gonna use that output, f of x, to substitute in function g. So you're gonna actually use the range of function f as a domain for function g. And this is what's written here. The domain of g composition f consists of the x values of the domain of f. As we said, we have the x values which represent the domain of f, for which f of x, which is the output of the first function, is going to be used as a domain for function g. This is more like explained here when you're going to take f of x and substitute within g. Take care that g is your main function, and the second one, f, is the function you're going to use to substitute in g. If you have them in a different order, like if f comes first, it's going to be different. Take in consideration that function composition is not commutative. So f of g of x is not always the same as g of f of x. Now this will be much clearer to you when we work with examples. So we're going to look at our first example and try to solve that. It says here, let f of x equal x squared and g of x equal x minus 3, and find each value or expression. Now I want to find f composition of g, and as we said, our main function is going to be the first one, which is f. F is equal to x squared. Okay, now am I going to write that as x squared? No, I am going to write that f is going to be my main function, and I'm going to substitute in f with the other function, which is g of x. Okay, so f is supposed to be x squared. Instead of writing x squared, like let's say this is x, I'm not going to write x, I'm going to just write the square. And instead of the x, I'm going to substitute using the second function. Like I'm going to take g of x and substitute here, which is x minus 3. So what did you do? You took the second function and use it as a domain for the first one. So instead of writing x squared, I removed the x and put parentheses, and I substituted with g. Then you simplify. Now this is basically x squared minus 6x plus 9 when you try to multiply the binomial by itself. Let's look at the second one. Now this is the opposite. I have g first, and I'm going to use f of x to substitute in g. So let's do the same thing again and see how that they are not commutative. It's not the same. So g is my main function, and I'm going to use f of x to substitute in g. Again, now g is x minus 3, so I'm going to put here parentheses for x. I'm not going to write x because I'm going to use f of x as a domain, minus 3. Now I'm going to take the other function, which is f, the second function, and substitute here, which is x squared. When you simplify, your answer is x squared minus 3, which is not the same as x squared minus 6x plus 9. This means that the composition of functions is not commutative. Now let's look at another question. Now here we have, let g of x equal 2x only, and h of x equal x squared plus 4. Find the values of the expression. Now g composition H of A. Now, it's not of X. So what are we going to do? We're going to remove each X and substitute with A. Which function am I going to start with? I'm going to start with this one. So instead of writing 2x, I'm going to write 2 and put parentheses. Inside the parentheses, as we said, we should put x squared plus 4. However, I know that I'm not supposed to substitute for x squared. I'm substitute for a. So it's going to be a squared plus 4. Then you simplify. This is going to be 2a squared plus 8. And this is the final answer. Now here, you have g composition g. So the same function, composition itself. And I want that for the value a. So I'm going to start with g, which is 2x again. I'm not going to write x, I'm going to write parentheses. I'm going to substitute with the second function. Well, the second function is also g. Am I going to use x? No, I'm not going to use x, I'm going to use a. So that's a 2a. Then you simplify. Your answer is going to be 4a. What about h composition h? Well, h of x is x squared plus 4. I'm not going to write x because the domain will change. I'm going to just write something squared plus 4. What will happen to my domain? I'm going to use the same function again, which is x squared plus 4. However, I'm not going to substitute with x. I'm going to substitute with a. So instead of writing x squared plus 4, I'm going to write a squared plus 4. And all of that is squared. Now, when you simplify this, take in consideration that this is a squared plus 4 multiplied by itself, which is a squared plus 4 again. Your answer is going to be a to the power of 4 plus 8a squared plus 16 when you use distributive property. This is only for this. So I have a to the power of 4 plus 8a squared plus 16. This is the answer for this part plus the 4 I have. When I simplify, I'll get a to the power of 4 plus 8a squared plus 20. And this is your final answer. What if I have a number like here? So instead of x, I'm going to be using -5. But before I do that, I'll have to write the relation. Now my main function again is h. h of x has x squared plus 4. I'm changing the domain. So instead of writing x, I'm going to leave parentheses and square plus 4. Don't forget. Now inside that parentheses, what I'm going to substitute with? Function g. Function g is 2x. However, we're not using x, we're using this value, -5. So I'm going to substitute here for 2 multiplied by -5, which is -10. -10 squared is 100. 100 plus 4 is 104. Well, it's a number, so life is a lot easier when you want to simplify. Now my last question. My main function is g. So I'm going to write g. And instead of writing 2x, I know I'm going to change the domain. So I'm going to leave that as parentheses. What do I substitute with? Value of h. h here is x squared plus 4. Do I put x squared? No, I'm going to put the 0. So it's going to be 0 squared plus 4. Well, 0 squared is 0, plus 4 is 4, and 4 times 2 is 8. Now, what have we done so far? We have seen how we work with compositions of functions. Even if I want to do the composition with a variable x, or I'm going to substitute for a variable x with another value, which is either a variable, like when we had a here, or even a number like when we had -5 here. I have a group of questions for you to practice and see how it works for you. You can write the answers in the comments and I'll let you know if they're correct. In this case, we have 3 functions, actually 4 functions: f of x, g of x, h of x, and j of x. Take in consideration that if f here is your first function, then this is your main function. You're going to remove the x and substitute with the second function for this value instead of the variable like we said before. Now, I hope this has been helpful for you. This was our second video about operations on functions. The first one was the video where we added, subtracted, multiplied, and divided functions. Now, I hope this has been helpful for you, and thank you so much for watching.